What's happening, science friends? You might remember me talking about the particle theory of matter. All matter is made of tiny particles called atoms or molecules. There's space between the particles. The particles are in constant motion. The particles are attracted to each other, and as temperature increases, the particles move faster. And today we're going to really focus on point number one. All matter is made of tiny particles called atoms or molecules. Now, molecules are just atoms joined together. We're going to really focus today on the structure of the atom. Well, all right then, science friends. You can see that I have built a model of the atom. I've actually built it out of atoms. And before we get started, let's kind of look at who are our main players in this game. Now, I know I just told you that all matter is made of tiny particles called molecules or atoms, and I told you all molecules were made of atoms, but now I have to tell you something else. There are subatomic particles. All atoms are made of these: protons, electrons, and neutrons. And you might be like, Dave, that's too much for me. And I'll say, well, can you remember the word pen? P-E-N. Protons, electrons, neutrons. Can you remember the word pen? Good. You know the structure of the atom. Now, let's look at these things. Okay, let's look a little bit more detail at the proton. Protons are kind of little particles like this. I know, this is like a magnet. And they have a positive charge. Now, you might argue, I guess if Elon Musk had discovered the proton, would he have named it an X charge? I'm not sure. But it has a positive charge. Now, the positively charged protons are counterbalanced by the negatively charged electrons. So electrons have a negative charge. And then neutrons. I wonder what the charge is on neutrons. They got no charge, nothing. They're neutral. So, subatomic particles, protons, electrons, neutrons, spell pen. Protons, P, positive. Neutrons, neutral, neutral. Electrons, the other one, negative. Remember that. Okie dokie, friends, check it out. This is our model of the atom. And you can see here, you got two main parts to the atom. In the middle, you have a nucleus, and that's where the protons live. Orbiting around the outside of the nucleus, you have something that's called an orbital, but I prefer to call it an electron shell, also known as an electron cloud. Now, in this nucleus, I have one lonely proton, and orbiting around it, to make it a neutral atom, I have one electron. You can see negative, positive, 1, 1. These charges equal. I should just mention right now, this will make you think that protons and electrons are about the same size. They are not. An electron is about 1/2000th the mass of a proton, so significantly smaller. Other thing you need to know is this: the nucleus, very, very small relative to the electron cloud, and the protons just sort of sit there in the nucleus. They vibrate a little bit, but they don't move around. Now, the electrons move, but not in the way you've necessarily been taught. They move randomly. They just sort of like vibrate around and moving around in sort of any given direction. And you know what? They're hard to locate. And in fact, if you try to calculate the location of an electron around the nucleus at any given time, you won't be able to beyond just saying there's a probability that it will be in one place or another. And that bugged Einstein. He said, God doesn't play dice with the universe, but he kind of does in this case, and that's what quantum physics is all about. But I'm not here to talk to you about that. Let's back it up a little bit and let's just look at this atom. Do you think you can get it? Come on, you can get it. What makes this? And what is this? This is hydrogen. Symbol H. Why? Because it has one proton in the nucleus. That's it. That's all. If you have one proton, you are hydrogen. What if you have two protons? So, in the event that you have two protons in the nucleus, something different happens. Now, if you have two protons in the nucleus, you're going to have two electrons in random places within this electron shell, within this first energy level. But let's get back to the nucleus. I've added something, haven't I? Those zeros, do we remember what they are? I hope we do. They're neutral. They're neutrons. And I had to add some neutrons into the nucleus. Why is that, Dave? Well, what do opposite charges do? Opposites attract. Like charges repel. If you try and cram 2 protons into the nucleus, they're not going to like that. They're going to try and push each other apart and blow the nucleus up. So what do we got to do? We got to give them some glue to stick them together. And what's that glue? Those neutral neutrons. Look how nice and happy these atoms sit together in the nucleus. And meanwhile, in our electron shell, we have 2 electrons floating around. And what do we have here? We have helium. Symbol He. Now, you don't ever get helium bonding with more helium because that would be funny. He, ha ha, ho ho. Okay. Now, that is helium. What do you think would happen if I was to add another proton? Would I still have helium? Let's see. Okay, I did it. I added another proton, and if you're astute, and you're going to notice something kind of messed up. When I added another proton, I didn't just add 1 more neutron, I added 2. How come that is the case? Well, guess what? This particular kind of atom likes having 4 neutrons. Now, could it have 3 neutrons? It could have 3 neutrons. It could survive just fine with 3 neutrons in there. It would just be a more rare form of the atom. We would call this more rare form with a different number of neutrons. Do you know what we'd call that? We would call that an isotope. Now, you're also going to notice something a little bit different over here. What is this? We have 3 electrons to balance out the 3 protons, but we had to add that 3rd electron in a new shell. We had to create a new electron shell for it. Why is that, Dave? Well, because the first shell fills up with 2. Why? I don't know. I wish someone did. They could tell me. That's another discovery for another day. But as it stands right now, that's my structure of the atom. I hope you enjoyed it. Thank you for watching my science video. Peace.